In today's video, we're going to be going over exponentials. So first, we're going to learn all the exponent rules, then learn how to simplify expressions with exponents, then learn how to write in scientific notation, and finally learn how to solve exponential equations. So here are the exponent rules. In the product rule, when you have the same base, you can just add the exponents. So a to the power of x times a to the power of y would be a to the power of x plus y. In the quotient rule, the same applies, but the opposite. If you have the same base, you can subtract the exponents. So a to the power of x divided by a to the power of y becomes a to the power of x minus y. In the power rule, when you have a variable raised to an exponent and then raised to another exponent, you would just multiply the exponents. So a to the power of x raised to the power of y is just a to the power of x times y. So the power of a product, when you have two variables raised to an exponent, each variable is raised to that exponent. So ab in parentheses raised to the power of x becomes a to the power of x times b to the power of x. The power of a fraction rule, when you have a fraction, you would see that exponent in the numerator and denominator. So a over b to the power of x is a to the power of x over b to the power of x. And whenever a number is raised to 0, it's equal to 1. Negative exponents, whenever you do that, you're going to flip it, or basically it's equal to the reciprocal in order to make it positive. So a to the power of negative x would just become 1 over a to the power of x. Fractional exponents. When you have a variable raised to a fraction, the variable would be raised to the numerator, and then outside of the square root symbol, you would have the denominator. So a to the power of x over y would be equal to y, the square root symbol, a to the power of x. And remember, when you cannot distribute an exponent to an expression that's attached by multiplication or division. So you can't do x minus y to the power of a and make that x to the power of a minus y to the power of a, and then you can't do x plus y to the power of a is equal to x to the power of a plus y to the power of a. That's not how it works. So now let's practice these skills. So 2 to the power of 2 times 2 to the power of 3. Because the base is the same, you would just add the exponents. So 2 to the power of 2 plus 3, which is 2 to the power of 5. Now we have 2 to the power of 2 divided by 2 to the power of 3. So remember, we would subtract the exponents. It will be 2 to the power of 2 minus 3, which is 2 to the power of negative 1. And remember, if you have a negative exponent, you can always find the reciprocal to make a positive. So the positive will be 1 over 2. Now if we have 2 to the power of 2 raised to the power of 3, you would just multiply the exponents 2 and 3. So this would be 2 to the power of 6. Now let's say you had variables involved. If you had 2x raised to the power of 2, it would be 2 raised to the power of 2 and x raised to the power of 2. So it's 4 times x squared. And what if you had a fraction? If you had 2 over x raised to the power of 2, then the 2 and the x each have the exponent 2, so it would be 4 over x squared. And anything to the power of 0 is 1. And if you had something raised to negative power, such as 2 to the power of negative 2, you could find the reciprocal to make a positive, which is 1 over 2 to the power of 2, which is 1 over 4. And if you had a fraction, let's say 2 to the power of 2 over 3, then you would rewrite this as 3 to the power of 2 squared, and that's just 3 square root symbol 4. Now let's simplify expressions with exponents. So let's say you're given the problem 3x squared y cubed times 2xy. Let's combine like terms to make this easier. So 3 times 2 is just 6. X squared times x, remember we're adding the exponents, so it's x to the power of 2 plus 1, which is x cubed. And y cubed times y will be y to the power of 3 plus 1, which is y to the power of 4. And then combine like terms, 6 times x cubed times y to the power of 4. Now we have 3 times x to the power of 2 times y cubed divided by 2xy. So let's combine like terms again. 3 divided by 2 is 3 over 2. X squared divided by x, remember we're subtracting the exponents now. So it's x to the power of 2 minus 1, which is x to the power of 1. And y cubed divided by y is y to the power of 3 minus 1, which is y squared. Now once we combine this, it's 3 over 2 times x times y squared. 3xy squared, all raised to the power of 3, what would that be equal to? So you're going to cube 3, you're going to cube x, and you're going to cube y. So 3 cubed is 27, x cubed remains as x cubed, and y raised to the power of 2 times 3 becomes y to the power of 6. And let's say we had 3 over x squared raised to the power of negative 3. So this would be 3 over x raised to the power of negative 6. And remember, finding the reciprocal would make this positive, so 3 times x to the power of 6. Let's try one more. X raised to the power of negative 4 times x cubed over x squared. So first we're going to combine the numerator, so x raised to the power of negative 4 plus 3 all over x squared, and that would be x raised to the power of negative 1 over x squared. And remember, finding the reciprocal will make this positive. It will be 1 over x squared times x, and that's 1 over x to the power of 2 plus 1, or 1 over x cubed. Now let's try something a little harder. If you have 6x raised to the power of 3 over 5 times y all over 2 times x to the power of 2 over 5 times y to the power of 1 over 5, what would it be? Let's just combine like terms. So 6 over 2 would just be 3. X raised to the power of 3 over 5 divided by x raised to the power of 2 over 5, you would just subtract the exponents. So x raised to the power of 3 over 5 minus 2 over 5, and that's x raised to the power of 1 over 5. Y divided by y raised to the power of 1 over 5. Again, subtract the exponents. This would be y to the power of 1 minus 1 over 5, which is equal to y to the power of 4 over 5. So once we combine this, it becomes 3 times x to the power of 1 over 5 times y to the power of 4 over 5. Let's try something else. If we had x squared times 4 square root symbol x squared over the square root symbol x raised to the power of 5 times 4 square root symbol x raised to the power of 3, what would that be? So first, let's change the square root symbols to make it easier to read. So it will be x squared times x raised to the power of 2 over 4 all over x raised to the power of 5 over 2, and times x raised to the power of 3 over 4. So once we combine these exponents, x raised to the power of 2 plus 2 over 4, and x raised to the power of 5 over 2 plus 3 over 4, we know that 2 plus 2 over 4 is equal to 10 over 4, and 5 over 2 plus 3 over 4 is 13 over 4. 10 over 4 minus 13 over 4 is negative 3 over 4. And to find the reciprocal, making it positive, would make this 1 over x raised to the power of 3 over 4. Now let's review scientific notation. First, what is that? Remember, it's when there's a number greater than 1 but less than 10, and then times 10 to whatever exponent power. So for 3.5 times 10 to the power of 5, what would that look like if it wasn't in scientific notation? So 3.5, you're going to add 4 zeros, and as you can see, each hop would represent a power of 10. So that would actually be 350,000. And what if we had 3.5 times 10 to the power of 0? As we know, any number to the power of 0 is 1, so 10 to the power of 0 is 1, so 3.5 times 1 is just 3.5. But what if we had a negative number? If we had 3.5 times 10 to the power of negative 5, when you're going from smaller scientific notation to larger scientific notation, you're moving your decimal point in the left direction. So 3.5, you would move the decimal point, add 4 zeros to the front, and then move the decimal point in front. As you can see, this represents each power of 10. This would be 10 to the power of negative 5, 10 to the power of negative 4, 10 to the power of negative 3, 10 to the power of negative 2, and 10 to the power of negative 1. So remember, when you're moving from greater scientific notation to lesser scientific notation, you're moving the decimal point to the right, and the opposite would apply if you're moving from smaller scientific notation to greater. So arithmetic operations with numbers were in using scientific notation. Now we're going to apply the skills we used previously. So in the equation, 3.5 times 10 to the power of 12 plus 4.5 times 10 to the power of 15. First, what we're going to do is make sure the exponents are equivalent. So we want to make 10 to the power of 12 become 10 to the power of 15. So let's make 3.5 times 10 to the power of 12 have an exponent of 15. what we can do, because we're moving from smaller to larger, we're going to move the exponent to the left. So add 2 zeros in front of the 3.5 and move the decimal point. So this will actually be 0.0035 times 10 to the power 15. Now we can add 0.0035 and 4.5 and keep the power of 10. So it will be 4.5035 times 10 to the power 15. Now let's look at another problem. If we had 5.7 times 10 to the power 4 minus 4.7 times 10 to the power 5, how would you approach this? We want to make 10 to the power 4 become 10 to the power 5. So we would add a 0 in front and move the decimal point one place to the left. So it would be 0.57 times 10 to the power 5. 0.57 minus 4.7 becomes negative 4.13 times 10 to the power 5. Let's try another problem. If we had 6.3 times 10 to the power 4 divided by 5.3 times 10 to the power 7, what would we do? So we can move 10 to the power 7 to make it 10 to the power 4. That's just easier for me, but you could take whatever approach you want. So that would become 5,300 times 10 to the power 4. Now we can divide them. 6.3 divided by 5,300 times 10 to the power 4. But now, so that would be 0.00118 roughly times 10 to the power 4. We want to make it in scientific notation, so we need to move the decimal point until we get a number greater than 1 and less than 10. So this would actually be 1.18 times 10 to the power 1. And our final question, 6.2 times 10 to the 4 times 7.2 times 10 to the 3. So 7.2 times 10 to the 3, that would actually be 0.72 times 10 to the 4. And once we multiply that, 0.72 times 6.2, we get 4.464 and times 10 to the power 4, because it's already in scientific notation. Now let's look at equations. So remember, you want to get the bases equivalent first, so you can set the exponents equal to each other. In this problem, 2 to the power of x is equal to 2 to the power of 4. The bases are already equal, so we can set x equal to 4, and that's our solution. But what if you had something harder? If you had 16 to the power of x plus 4 is equal to 32 to the power of 2x minus 10. First, what is 16 equal to? 2 to the power of 4. And 32 is equal to 2 to the power of 5. So now that the bases are equivalent, you can set the exponents equal. You can have 4 times x plus 4 is equal to 5 times 2x minus 10, or 4x plus 16 is equal to 10x minus 15, 66 is equal to 6x, 11 is equal to x. Let's do another problem. What if you had 9 to the power of 2x plus 3 is equal to 1 over 27 to the power of 3x plus 1? 9 is just 3 to the power of 2, but 1 over 27, remember 27 is equal to 3 to the power of 3, and because you're in a fraction, you will be finding the reciprocal of 27. So if 27 is 3 to the power of 3, then 1 over 27 is equal to 3 to the power of negative 3. 3 to the power of 2 times 2x plus 3 is equal to 3 to the power of negative 3 times 3x plus 1. The bases are the same, we can set the exponents equal. 4x plus 6 is equal to negative 9x minus 3, 13x is equal to negative 9, x is equal to negative 9 over 13.